Evangelista, and welcome to this episode of Evangelista Science. We're going to talk about today energetics and thermochemistry. Let's go ahead and get started. So the first thing we have to talk about is the difference between temperature versus heat. Temperature is going to be the measure of the average kinetic energy of a system, while heat is going to measure the energy transferring between one system and another. We can also call this enthalpy. And energy transfers from something that is hot to something that is cold. What is the difference between the two? So we see here this 1,000-degree knife, and we see here the sparks that are coming from the sparkler that we have over here. Obviously, this 1,000-degree knife, if you were to put this on your skin, would cause some pretty hard damage. However, we can hold this sparkler pretty close to the sparks without really worrying about getting burned. That's because even though the sparkler reaches a temperature of about 2,000 degrees, and the 1,000-degree knife would be about 1,000 degrees. Even though this has more temperature, the 1,000-degree knife has more heat, or this ability to transfer more energy, because it has more mass. The sparkler here, these sparks have such little mass that even though they have such a high temperature, they don't carry with them much heat, so that when they touch your hand, they're not really going to be able to transfer a large amount of heat. And so the classic example is you have a bathtub and you have a cup of coffee or a coffee mug, and they're both filled with water. The coffee mug is at 90 degrees Celsius and the bathtub is at 60 degrees Celsius. Now, if you're sitting in a pool and the pool is, let's say, 25 degrees Celsius, and you wanted to warm it up, which would you choose to pour into the pool? Would you choose to put the 90-degree coffee coffee cup of water or the 60-degree bathtub of water? And the correct answer would be you would put the bathtub, because even though the coffee cup has a higher temperature, there is more heat and more energy to be transferred because you have more mass in the bathtub. Now, talking about the average kinetic energy. So temperature is a measure of the average kinetic energy. What does that mean? When we look at a system, the temperature here is 300 Kelvin. That means that on average, these particles have the energy of about 300 Kelvin. Well, notice here that some particles are moving really slowly and some particles are moving really, really quickly. And this explains why. So when you leave a glass of water out on the table and you leave it there for a while, some of the water molecules that are in liquid form will actually go and evaporate into gaseous form. And we know that water boils at 100 degrees Celsius. So why is it that some of the water molecules actually escaped into gas form, even though it was maybe at room temperature at 25 degrees Celsius, when you need 100 degrees Celsius for water to boil? Now that's because temperature is only an average. So even though that water is on average 25 degrees Celsius, and on average the molecules are moving at that energy, since it is an average, some of the molecules might actually be moving fast enough to actually vaporize from liquid to gaseous form. And so we have to talk about standard enthalpy change. Again, we talked about the difference between temperature and heat. So we're going to see this symbol a lot. And what this symbol means is the triangle here, that just means change in. H is enthalpy, or the heat energy. This little circle theta is going to be the standard conditions. And you could have a standard heat of formation, of combustion, of neutralization, of a reaction. We'll talk about the X later. But since these are standard conditions, these are at 100 degrees kilopascals, at about 1 mole per decimeter, and all substances are in their standard state. Now, what does that mean? It means that at 100 degrees kilopascals and about 298 Kelvin, what state would you find these substances in? So that's the standard enthalpy change. Another concept we have to talk about is this concept of absolute zero. Absolute zero is the lowest temperature we can achieve because at that temperature, since temperature is a measure of the average kinetic energy, there is no more kinetic energy at absolute zero. And that's why we have the Kelvin scale. The Kelvin goes all the way to zero. That is the lowest temperature possible. That's why we have the Kelvin scale. I know some of you guys were wondering, why is it that I have to convert constantly between Celsius and Kelvin? Why can't we just have one unit of measurement for temperature? Let's not even mention the abstract, conversion to Fahrenheit. But the reason we have Kelvin is because Kelvin at zero actually represents absolute zero. And one last concept for today is this concept of exothermic and endothermic. In exothermic reactions, we are releasing or exiting heat, so heat is actually going to be released. This happens in combustion reactions when we release a lot of energy. Also, neutralization reactions, those also release a lot of energy. And so we can see that if this is H, if this is the energy, that the reactants are, since we released energy, the reactants are going to be higher in energy than the products, and delta H, or the enthalpy, is going to be negative. Now, if it's endothermic, if we are actually absorbing some energy, then the products are going to be higher than the reactants, and delta H is going to be positive. So here, for example, we have combustion of methane. When methane burns, it's going to release energy. Here we have the equation for, you probably might notice this, for photosynthesis. And photosynthesis absorbs light energy, and so this is actually an endothermic reaction.